So when Eugene asked me to give this talk, he kind of gave me a couple of different options as to like topics to pick, and Scala 3 upgrading seemed like the most topical one. All the other ones were boring things like functional programming and stuff. So the what I wanted to talk about is like the fact that we are upgrading to Scala 3, and like that's kind of around the corner. I think there's a lot of questions that people have about it, and I've actually been like working on this for a while, not on the language, but actually on the upgrade for the ecosystem. So I thought it would be pretty cool to like share some findings and share some thoughts, and try to back up what I think is the proper conclusion from this. So I'm going to start off by showing you some Scala 3 source code. All right, so this is a Scala 3 application. And we'll go through a couple different examples of these, and we'll kind of judge how hard it's going to be for us to really adapt to all of the changes in the language. Because you've probably heard about like significant indentation and like given instead of implicit and like all these sorts of things. It's probably sounds very very intimidating. So let's just see exactly how bad it's going to be. What's the damage? All right. So this is Scala 3. Looks pretty reasonable. Not too much changed there. Let's maybe do something a little bit more elaborate. Okay, let's do another Scala 3 application, but we'll do some functional programming. Okay, we'll use Cat's Effect. We'll even use Cat's Effect 3 just to be fancy, and we'll see what this looks like again in Scala 3 using the Scala 3 compiler. Okay. I don't even see significant indentation here. Like we've got curly braces and stuff. Like I was promised those would be gone, but apparently they're still here somehow. Definitely Scala 3. I compiled it with Scala 3 earlier today. So, we're still good, but maybe I'm cheating. Okay. Like I'm still doing some relatively simple applications. Let's do something complicated. Okay. Let's do something with implicits and functions and polymorphism and stuff like that. We heard that all that stuff is changing. So, with type class encodings and stuff like that, what does this look like in Scala 3 now? Okay, well, here's monoid. Okay, we've got a little monoid type class. We define some sort of implicit syntax for it. Still Scala 3. I feel kind of lied to. Let's go really ham here. Okay, let's look at generalized algebraic data types. Okay, GADITs. This is a relatively niche feature in Scala. Like, libraries will often use this in implementations, but applications relatively seldom take advantage of it. This is a thing that's traditionally been a little bit in flux in Scala 2. Scala 3 has a more concrete foundation for it. So clearly it's got to be really, really changed. Okay, it's got to be very, very, very different. So again, Scala 3 source code, and really no difference. Okay, we've got a sealed trait here, 0 of type A. We've got 3 different instances of it, concretely string into Boolean. Do some pattern matching on it. And this isn't even significant indentation. It's just equals and then, a single expression on the pattern match. So like Scala 3. Let's do one. Go ahead, Josh.
We have one question though.
You have a question already.
Is this with compatibility mode or without compatibility mode?
Great question. In this case, I did turn on compatibility mode, but I didn't actually have to. So all of these things would have compiled without that.
Okay.
So compatibility mode, to be clear, what compatibility mode does is it takes the few syntactic constructs whose meaning is whose like individual source incompatible meaning has changed in Scala 3, and it makes them behave with the Scala 2 semantics. In this case, I don't actually think I hit any of those cases. I could double check that if people are curious.
Yeah, I think the specific question, sorry, from April was, isn't implicit value class legacy Scala 2 support, i.e., would you consider it Scala 3?
I would consider it Scala 3. That's a good question, because I consider like the majority of Scala 3 is actually inherited from Scala 2, and that's like a lot of the point of this talk. So yeah, implicit classes, I do consider them to be part of Scala 3. They may not necessarily be the way that we will be using Scala 3 in the future, but they are definitely part of Scala 3. And I think that's an important distinction. Good question. Let's give one more example here, just in case people think I'm really, really cheating by avoiding hard stuff. HList. You've probably heard that like Scala 3 has a bunch of new type level like metaprogramming stuff and like different tuples and things like that. So I just wrote an H list in Scala 3, and it looks exactly like the H list in Scala 2. I mean, even the use site is exactly the same. So like all this works, all this compiles on Scala 3, exactly as I wrote it here. So my contention, and this goes to April's question basically, is Scala 3 is Scala. So anecdotally, when you have the right flags on, source compatibility is around 95 to 99%. That's completely anecdotal. All right. This is just based on my experience sort of trucking through a number of different code bases on this stuff. Usually, the migration steps for getting your project forward to Scala 3 are, number one, add spt.a to your build, which won't be necessary for very long. Number two, change your Scala version. Number three, double check your libraries. And number four, profit. And that's pretty much it. There's usually very few things you have to do beyond that. And so if this sounds like a familiar process, that's because it is. For the most part, Scala 3 is just another Scala release. You can treat this more or less the same as you treated the upgrade from Scala 2.12 to 2.13. And my claim, actually, and I kind of hinted at this in the talk abstract, is that this is easier than upgrading between traditional Scala versions. Because we have this
interruption.
Oh, yes,
so,
Eugene?
What about all of the metaprogramming stuff?
The metaprogramming stuff. I will get to that a little bit later on in the talk, but an important thing to note is that the metaprogramming stuff by itself is just additive to the language. Like it adds functionality to the language, doesn't take something away. Macros, of course, which people used for metaprogramming previously, are significantly changed, and I will get to that a little bit. And you have to sometimes replace things that had been macros with the new metaprogramming stuff in the language. But the point being that the metaprogramming stuff doesn't step on anything that you had in Scala 2. So if you have a code base that's in Scala 2.13 right now, and you want to get it up to Scala 3, the metaprogramming stuff doesn't matter to you.
I mean, so I guess the real question is the Scala 3 metaprogramming a superset of the Scala 2 metaprogramming toolkits, or are there kind of like a Venn diagram of maybes?
In terms of capabilities, I think it's fair to say that the Scala 3 metaprogramming is a little more restricted than what was possible in Scala 2, at least in theory. Because the thing is that in Scala 2, you really didn't have many guardrails. Like, if you were sufficiently creative, you could use a Scala 2 macro to like overwrite the compiler and completely change the language. An example of this is I have a library which compiles in Scala 2, which uses a macro to rewrite the implicit resolution system. So you actually get a completely new implicit resolver that I wrote in my macro. And that's just a library that you can pull in. You cannot do that in Scala 3. And I would argue that that's probably a good thing. But conversely, in Scala 3, the functionality that's provided by the metaprogramming facilities is generally speaking a superset of what was conventionally used with libraries like Shapeless. It's encoded a little differently, so that can kind of trip people up. But this, if we're judging by Scala 2 usage, this isn't something that appears in most people's code bases. This is stuff that appears in libraries like scodec or Circe or something like that. Not so much in like, my cool service, which is handling login requests.
Thanks.
So migration. I am going to make the claim that the Scala 3 migration is actually the easiest Scala migration ever between Scala versions. And I actually say that with some degree of seriousness because, I've been doing Scala migrations for a long time. I've done some pretty straightforward ones, 11 to 12 is a pretty easy jump, especially if you're already on JDK 8. I've also done some really, really hard ones. 2.7 to 2.8 was a really big jump. People at the time were saying that it should have been called Scala 3, like Scala 2.8. I think this one is the easiest one I've ever done. And a large part about that is the fact that there are these tools that are provided by spt.a and the Scala 3 compiler for consuming libraries published against Scala 2. So if you publish a library against Scala 2.13, you can use with .a compat to consume that library directly within a Scala 3 build. Now, there are some caveats to this, but like this alone makes it very easy to kind of incrementally experiment with things and sort of shuffle forward the migration and do some of the work before things are cross-published, which is not an option we have ever had before. So that makes a huge, huge difference. There are no changes to the standard library. The Scala 3 standard library is the Scala 2 standard library, modulo some overlays that are necessary just to get the compiler to work. I mean, you're not going to see these in user code at all, but it's literally the same standard library, and that's really incredible. So far, not all of the libraries in the ecosystem are published for Scala 3 yet. There's a large number of them that are. But this is just basically, I mean, Scala 3 isn't even out yet. So like, why should we be surprised? This is kind of just like when Scala 2.13 was first released, or when Scala 2.12 was first released, where like there was a ton of stuff that just wasn't cross-published yet. And the only difference is that with .compat gives us some flexibility, some wiggle room to actually use this. So the compatibility story is actually like quite good. I mean, it's not perfect, but it is very, very, very good. And it gives us a lot of power. An example of where you can use this power, I'm a weirdo who likes using the Spex2 testing library, right? And Spex2 currently is not published for Scala 3, but I'm fiddling around with stuff. I want to be able to write code. I want to be able to write tests in the library that I'm used to. Because Spex2 is published for Scala 2.13, I can use this incantation here with .compat and then just write my tests using Spex2. And again, Scala 3 code here, and everything works just fine. So that to me is really cool, right? So is this the end of the talk, right? Like, are we just done? Is this actually the easiest Scala upgrade of all time? Well, no, nothing in software is ever that simple. So with .compat is not perfect. It's really good, okay, but it's not perfect. And the biggest problems of it start to appear when when you're working on a library that has with .compat, and then you want to work on something that descends from that library, and the libraries in turn haven't been upgraded. You can create these weird, unfortunate diamonds, and I'll have a better example of this in a second. Macros. So we kind of alluded to this earlier, but macros in Scala 2 were really the Wild West. And so many different things were possible that really shouldn't have been. Scala 3 completely redoes that system, and any source code which uses macros, any library which uses macros has to be revised to work on Scala 3. Now, I would posit that most people's application code is not using macros. I think you're probably using macros indirectly through libraries like Shapeless or Magnolia or Circe, but you're probably not writing macros yourself. And that means that it's on the library authors to actually do this upgrade, which fortunately they are. Here's another big ticket item: bugs. So we tend to forget this because we just kind of use the language and live here all the time. But there are a ton of bugs in Scala 2. Like, it's a really buggy compiler, so much better than it used to be, okay? And this is not dismissing anybody's work. It's incredible how far it's come. But there are a lot of very subtle bugs in Scala 2 that we accidentally exploit on a daily basis without even realizing it. Just stuff that we write that hits bugs, and we think it's supposed to work that way. It's not supposed to work that way. It just does. And in Scala 3, it's fixed, right? Like, lots of things are fixed in Scala 3. And this tripped me up more than almost anything else.
Question about that.
Yes.
What areas of the compiler are those, accidentally exploited bugs? What areas of the language are those typically in?
The most common areas in my experience are subtyping, especially subtyping as it relates to polymorphism, and implicit search. So some concrete examples of this: subtyping as it relates to polymorphism usually means variance. And the Scala 2 compiler will very frequently consider things to be subtypes validly, or things to not be subtypes, based on very strange semantics. And that can in turn lead to different type inference results. It can lead to code compiling that shouldn't compile because the variance is unsound. I have an example from a while back, actually, that had like this covariant sort of ADT structure, where I built a structure that compiles just fine on Scala 2. But like, if you actually stare at it long enough, you realize that there's some implicit casting that the compiler is inserting because the type checking was unsound. And Scala 3 just doesn't let you do that. So that's a really good example. The implicit scope is another one where like you'll find that some implicits that Scala 2 just ignored, which in turn would mean that some implicits were unambiguous, Scala 3 finds them. And when you actually stare at it long enough, you realize that according to the spec, as far as we have it, it should be found, but the Scala 2 compiler, for whatever reason, isn't finding it. Type members are a very frequent source of that, where type members in Scala 2 are treated quite differently than they are in Scala 3. Good question. Final pitfall that I wanted to call out here is there are uncommon features that were changed or removed. So do while is one that you will probably hit if you write a lot of performance sensitive code and you don't use tailrec for some reason. So the do keyword is just gone in Scala 3, and it's not there even in Scala 2 compat mode. It's just actually gone. This was done partially because every while loop can be trivially rewritten, like literally with a Scala fix to, every do while loop can be rewritten into a while loop. So that's not really a big deal. But it is something that might trip you up if you have a lot of hot path code. So let's go over these one at a time and just make sure we really, really understand them. So pitfall number one, with.compat isn't perfect. Here's a perfectly normal situation. So I have my cool application, and I depend on Cat's laws because I'm doing some property testing based on type classes or something. And Cat's laws depends on Scala check because it does property testing, right? But I'm a weirdo who's using specs 2 instead of munit. And specs 2 has been published only against 213. So I'm using with.compat to get to specs 2, but specs 2 transitively depends on Scala check. And this is a problem because now I transitively depend on the Scala 3 version of Scala check via Cat's laws and the Scala 2 version of Scala check via specs 2. And this conflicts. So if you do this today, SBT will actually just tell you, don't do that, which is good. It gives you a relatively clear warning. It says this is a problem. And the solution to it is you have to insert an exclude. So this is the syntax you need, but you basically exclude the 213 version. You're kind of taking a little bit of a risk because you need to be certain that the binary compatibility story is there, but it does allow you to proceed forward when you're in this situation.
So here's a question from the chat of why don't you just use munit? Because it's munit.
It is
then you won't have a problem.
Then I just wouldn't have a problem. But then I wouldn't have a talk. So like I have to keep using specs 2, otherwise I wouldn't have these slides. Duh.
Okay. That makes perfect sense. Now, when you do this exclude, I have a question.
Mm-hmm.
Isn't there a chance that it actually is not binary compatible? The new version of Scala check and the previous one, so that it will just break horribly?
Yes, there is that possibility. And these aren't even new versions. These are different cross-published versions, right? Scala check, the same version published for Scala 3 versus Scala 213. So you're basically comparing the compiler backends for the two and the various encodings. There is a chance they won't be compatible. It's a very small chance. You can run Mima if you want to be really, really sure. In most cases, I would say if people are hitting this type of thing, I would hope they're only hitting it in test code. If you're hitting it in your production dependencies, then you might want to go bug some library authors like, say, Eric for specs 2 and try to get it published to Scala 3, because that's really the solution. I will note this is the exact same problem that we have always had with Scala version upgrades, like 212 to 213, for example, except we never could have contemplated this with 213 because we didn't have with.compat.
I just want to cut in and mention, you mentioned Mima. So Dale at Lightbend is actively working like this week on making sure that Mima works correctly with Scala 3 generated artifacts. He is hitting a number of compiler issues where Scala 3, he's finding that Scala 3 is doing things a little differently, and then Mima flags those. So he's reporting those upstream to the Scala 3 team. I think by the time, M3 will already fix some of those, and I think that will all be straightened out by RC1 time. That's
fantastic. I wasn't aware of any of that. Yay, Dale. Continue being a terrific human being. All right, macros, and not the type of macro that I took a screenshot of. So macros exist on Scala 3, but they are completely different. So as I mentioned, before, like macros in Scala 2 could do almost anything, including completely rewriting the compiler internally. Macros in Scala 3 can't do that, and they in fact can't do a lot of the metaprogramming things that we're used to being able to do, like white box macros and stuff. So that's a pitfall. Like if you have a library or something, or if you yourself for some reason wrote those types of macros, you're going to have some trouble upgrading to Scala 3. You're going to do things. I'll talk more about that in a little bit. Shapeless exists on Scala 3, but it's completely different from the shapeless on Scala 2. It's not source compatible. It offers different functionality. It's still useful, but it's a very different thing. So if you're using that type of functionality, yes, Eugene.
Yes. Let me flip the chess clock first. All right. So now that you've mentioned shapeless, this gave me an opener into just kind of asking about what possibility Scala 3 adds up, especially for the tuple stuff. Like I'm super interested in like the shape of the tuple. So like in Scala 2, tuple looks like a flat structure all the way up to 22, whereas shapeless is tuple, or the Scala 3's tuple is what tuple should always been, which is that it's basically, it only has 2 pairs, right? And it's the 3 pair is a nested pair of the tuple, 2 pair of pair, essentially. And
I would need to check on that, but I actually think it's an array under the surface.
Yeah. So it's yes. So internally it could be whatever, but it, as a type fiction, you can extend, like basically look into the head and the tail of it. And like, because I think shapeless, a lot of people use shapeless for that feature alone of being able to kind of like traverse over the product. I was just wondering, like, if that, like, what door would it open, and also like what compatibility headache can it cause?
I think you're thinking of Spark. Yes. So basically what you're getting at is the fact that, like, in the language, in Scala 3, the language itself, there are these metaprogramming features that people used to get from shapeless 2. And that used to be the only way you could get them, other than like Magnolia, or doing it yourself. And now you can just get them out of the language itself. So then what purpose does shapeless serve, and like things like that? The functionality that's in the language right now is a little early stage, I would say. If you go and you actually go to use it, there's certain things that work really, really, really well, and you're like, how did I ever live without this? Like head tail on tuple, for example. And there's other things that are a lot harder, like auto derivation, right? Shapeless is generic, exists in Scala 3 in sort of a language feature now, but it's very painful to use in its current form. Now, all this has been like bugged out and upstreamed, and like people know about it, and like people are going to work on this and make it better. But like right now, it's a little painful. Shapeless 3 wraps around that. So what Shapeless 3 provides you with is an interface which is just as nice to use as Shapeless 2, nicer actually, but is based on primitive language features rather than based on macros. And so you can kind of, it can kind of act as a little bit of a bridge to make things easier in the short term. Good question.
Okay. Thanks.
So question for you, did I catch that you said there's no such thing as white box macros in Scala 3?
There are no white box macros in Scala 3.
Good.
And no annotation macros either.
Yep.
It is that will trip up some small slice of the community.
I know we got rid of annotation, but I thought we still had white box, or did they get cut eventually?
The macro system went through a couple iterations.
I know white box was cut, then it was added back in.
I think they're out again.
Is it actually cut now?
Yeah, I think they're out. There's a variant of it which is similar to white box macros, which is the way that inline macros work. But the inline macros are hygienic, so I'm like, in practice, I think that pretty much prevents you from doing a lot of the stuff that you used to do with white box macros. I would be curious to be proven wrong on this, though. Like, that would be very interesting.
Yeah, I just basically I think you will have way more flexibility than you're making it out to be. There you have white box-ish. So there's a lot of white box use cases that you could still get away with. Some of the crazy things people want to do with annotations, for sure not. But here's the thing. It runs on the JVM, right? So, I mean, all you have to do is hijack the class loader with an agent. You can put whatever compiler you want in
Look,
there.
Josh,
I'm
stop
saying,
corrupting the children. Okay.
I'm just like, this is Java. Bytecode can be rewritten.
No, it
Everyone
can't.
does it. Everyone
Stop
does
it.
it.
No, not everyone does it.
We have a support group for you.
Only for you.
Like straight up though, can we do simulacrum, which is like really cool annotation macro to generate all the good stuff?
Simulacrum is being done with ScalaFix now.
The annotation stuff, I don't think you can do.
Yeah.
The ScalaFix route, that might be worth explaining briefly, like you know, how it's possible that ScalaFix could sort of fill in for, could substitute for an annotation macro.
Yeah, very briefly, because I don't want to hijack Josh's corruption talk, but the way that it works is ScalaFix can do sort of source code rewrites based on Scala metatrees. So what it does, the ScalaFix simulacrum library goes through and it looks for the old type class annotations, which used to be macros, and it just generates the source code, or the source trees, which correspond to that. So it'll generate an ops class and like, you know, sort of implicit forwarders and things like that. And it'll put that into the source code as a rewrite along with a comment guard that says this source code was auto-generated, please don't modify it. So aside from giving you flashbacks to C++, this gives you the functionality of annotation macros in Scala 3. And in fact, for some libraries, like for Cat's Effect 2, for example, I used that library to just generate the source code, and then I took the guards out because I was like, I'm never going to go back. And I just left it alone.
Only terrible people do that. Only terrible people.
Thanks, Seth.
And then you know, remove it.
Yeah. Yeah, I don't auto-generate code often, but when I do, I remove the guards.
You do it in your user's code as opposed to in your library.
Exactly. Yes.
Yeah, that's what macros are all about. I don't want to generate the code. I'm going to make your CPU spin and do it for me.
It's like a retrovirus for source code, basically.
Oh, there's a question in the chat room. It says, how is compiler plugins support in Scala 3?
Good question. So the short answer is Scala 3 does support compiler plugins. They're a little more limited than they were in Scala 2, which again, arguably a good thing when you remember like Miles Sabin, for example, came up with a compiler plugin that fixed SI2712, which probably shouldn't be possible. Parser modifications are also impossible. So Better Monetic 4, for example, can't be ported to Scala 3, but the plugin interface does exist. Existing compiler plugins are incompatible. So things like Kind Projector actually got pulled into the Scala 3 compiler, and other you know, sort of Scala compiler plugins will either have to be pulled into the compiler or rewritten against Scala 3.
I think it's a shame to lose Better Monetic 4. Like, I wonder if the Scala 3 team might relent on that if pressed.
I think there's definitely cracks in that armor. I mean, at the very least, some of the most useful functionality from Better Monetic 4, I think Martin is very, very open to including that. And Guillaume has like a pull request now or at least he has a draft pull request somewhere that tries to get some of that working again. Better Monetic 4 is pretty great. I basically can't live without it now. Good question, though. Any more? Any more from Josh?
One question. Shouldn't with Dotty compat flag its usage on artifact version?
That would be really nice. I'm not sure if you would do it as like put it as a version suffix or something like that. So it's like literally in the artifact that you published, or if it just like warns you when you publish, or maybe put some POM metadata in there that downstream SBT can consume. Any and all of those I think would be kind of interesting. It would be helpful if we had some SBT developers in the room who could, you know, maybe speak to this and possibly make it happen.
I don't think it's possible because it depends on the state of Maven Central, and we have to act like repeatable. or hermetic in Google terms. It's not hermetic, but
Yeah,
no, but
it's more a dependency resolution thing, right? It's not like that's 99% what that is. So SBT can fix its dependency resolver, but you want to make sure it's compatible with everything and all the build tools.
That makes sense. Yeah, I almost just wanted to like have enough machinery in there that we can get a warning about it. But I guess technically we get a warning now whenever you get the diamond conflict.
well,
I
the
mean-
discussion clock is 3 minutes, and Daniel has 7 more minutes to speak.
Oh, okay. Well, I should move very quickly and also tell
Yes.
Josh to shut up. All right, many many libraries have already done the work for you. So if you use like Circe or Doobie or Slick or something like that, Shapeless I already mentioned, Circe and Doobie and Slick have already ported all of their existing machinery forward to Scala 3. So if you're a downstream user of Circe generic, for example, you don't have to change anything. It will just magically work on Scala 3, the same as it works on Scala 2, even though the deriving machinery is completely different under the surface. So this is a nice thing that like the library ecosystem can insulate you from if you're a downstream user, which I would wager most of us are, at least at some point. Bugs. I'm going to go real fast. Scala 2 is a pretty buggy compiler. Again, not taking away from anybody's hard work. Like it's an amazing feat of engineering, but it's a very hard thing to do to compile Scala. And certain areas like gadgets, type members, implicit scope, covariance, subtyping, et cetera, are like really, really problem areas for the compiler. And a lot of libraries, especially libraries that do more advanced things with the type system, have built-in workarounds to these bugs, sometimes completely accidentally. And those workarounds behave differently on Scala 3 because in Scala 3, the bugs are fixed. So you can get some different results. So really, really quickly, here's like a simple example of this. This is like a little polymorphic function interface. We've got a covariant type constructor F and a function on here which does the whole super type G of F thing to try to get it and takes a functor constraint on the G. I'm not going to explain this code, just kind of take it at face value. If you try to call this code from within Scala 2 with a type constructor, which is itself, its parameter is declared to be covariant, this will fail. I need just a brief moment. I apologize. Discuss amongst you.
Is this when we're supposed to fill in time? I think it is, right?
Yep. I did not know that you could have variance syntax on the
Yeah.
underscore like that.
It's pretty awesome, right?
That's one word.
Yeah.
Josh.
All right, I am back.
Hey, long time.
Okay, so this will fail to compile on Scala 2. And the reason is the fact that like the F covariant and F polyvariant are actually not even the same type, and the Scala 2 compiler will not merge them together. What's up?
Quick question. When does plus underscore become the next cat's operator?
Oh boy. Plus the whole like trying to like put covariance on everything and like thread it through. It's like it's really hard to figure out how to do it correctly. I don't know. I get this code wrong all the time, and it's very like basically my point is that it's very, very buggy in Scala 2. It's unfortunate. So in Scala 3, this code works just fine, like basically the way that it's supposed to do. But in order to make stuff work on Scala 2, library authors have to do very, very weird stuff like this, which is you put these little like extra kind projectors things on here, and that apparently is enough to trick the Scala 2 compiler into working. But if you do this on Scala 3, it won't work anymore. So like this is a situation which can get really, really tricky if you are hitting these kinds of cases. And again, this is a bug in Scala 2, fixed in Scala 3, but working around it in Scala 2 causes it to break again in Scala 3, which is unfortunate. I did not expect this one, by the way. This was a very surprising one. Another example is this is the monadops class from cats. And these two functions on here are being added on to the sort of F of A. These type signatures, you actually can't call them on Scala 3, even if it's published against Scala 2.13 and like that type of thing. So you're doing with .compat. If you try to call them at the call site, the type inference will fail. And it turns out to be, this is just because the Scala 2 compiler does something very strange with the F. The constraint on the F is sort of figured out late in the type inference algorithm, whereas in Scala 3, it's very strictly left to right, and it needs to know the F earlier on. So the solution to this is kind of weird, but you have to use a Scala 3 construct to move the implicit block ahead of the type parameter. Otherwise, things no longer unify. And again, this is the Scala 3 compiler behaving in a way which is arguably a lot closer to the Scala spec, but the Scala 2 compiler wasn't, and so workarounds get missed. So moving forward super quickly, if you are running into problems migrating to Scala 3, using with.compat for libraries that aren't published yet, as long as you know how to use the exclude modifier and you know what it means, that's a fairly decent way that you can make some progress, again, in ways that weren't possible before in earlier Scala versions. Don't use macros directly. This has pretty much always been true. Macros have always been the Wild West, but really, really don't use them. Prefer type level techniques like implicit search. Adjust your API to avoid exploiting Scala 2 bugs, which is really difficult to do if you don't know where they are. But you eventually learn these sorts of situations and you try to move away from them. And at worst comes to worst, SBT does support version-specific directories for Scala 2 and Scala 3, which you can use to kind of get around this problem. So final subjective verdict. Was there a question?
No, that was a non-committal grunt.
Oh, okay. That sounds like a question.
I was going to ask a question.
Yeah.
Sorry. I'm taking all of the time for everyone who wants to talk to you, so I apologize. Yeah, use Scala 2 and Scala 3. Question, when do you stop using Scala 2? I know this is not an option for library developers, but we're not talking to just library developers, right? Like people who own applications.
Honestly, if you own an application and you are used to kind of upgrading to Scala versions relatively quickly, so you're already on 2.13, you upgraded to 2.13 within, a couple months of it being released, then go ahead and upgrade to Scala 3 on more or less the same timeline, as long as your libraries are all cross-published. And I think for the most part, as long as your tests pass, you're going to be fine. And that should apply to a lot of people. But more pragmatically, there are a lot of people out there that are on old Scala versions, Scala 2.12, even Scala 2.11. And I think it'll take a long time for the long tail to kind of work their way forward. People who are used to upgrading will upgrade. People who are not used to upgrading will not upgrade. And so I think Scala 2 will be around for a while from that standpoint.
I think I would amend that answer a little and say that I think that application authors that what's going to hold them back is tooling. So it's not going to be that the compiler isn't there yet. Like the compiler has been good enough for a long time now. I think it's the tooling that will hold actual shops back from upgrading.
Yeah, I agree with that. And the good news on that front is that the tooling is advancing very quickly. So there's a lot of interest in it. IntelliJ already works with Scala 3 for the most part. Metals already works with Scala 3 for the most part. There are caveats to all of this, but I think the tooling ecosystem and the library ecosystem have been taking this very seriously. So again, I think the story's pretty good. I've been happy anyway. And honestly, the Scala 3 compiler is so nice to work with. Not even just like the source code of the compiler, but I mean, the error messages it gives you are so much easier. It has very, very comprehensive implicit error messages, so you can diagnose problems. It's actually very nice. I do like all of my personal development against Scala 3 now, and then I backport it to Scala 2 because it's that much nicer to work with. So subjective verdict, okay? Out of the dozen or so, dozen plus projects I've migrated, only one of them had serious issues that took me a long time to work around. And for the most part, they were issues because of bugs in earlier versions of Dotty, bugs that have now been fixed. And they were fixed very, very quickly. So disclaimer though, I very rarely use macros. Like I don't write macros very often. However, when I do, I completely replace the implicit search, which is what Shims does. So Shims literally, as a library that replaces the implicit search in Scala 2, it splops it out in the compiler for its own version of it. And Shims took me just under an hour to migrate. So that's my only macro using project, and it's a whale of a macro, and I migrated it in just under an hour. So that's, not every project is going to fall into that category, but I was pretty impressed that it was that quick and that easy. And it literally just compiled almost on the first try. So that's pretty amazing in my book. Workaround usage is very, very rare. especially once you're working in an ecosystem of libraries that have all cross-published. I don't need to use crazy workarounds or like version-specific directories particularly often. And when I do, it tends to be for very specific things, especially when I need to maintain backwards compatibility with a Scala 2 binary API. If you're an application developer that's only publishing against a single Scala version, this is not an issue. And like a lot of the workarounds just kind of disappear.
So we do have a question on chat, which is, sorry, I have to reread it. How is the support for the cake pattern? Can you cake and union with intersection types? Related to that, I also want to ask about how much, you say you don't use macros, but you migrated shims quickly. Are you finding yourself using the new inline meta-programming techniques more often that are available, that aren't full-blown macros? So both of those questions, but one might lead to the other. That's why I'm asking them.
So the support for the cake pattern is, I haven't tried it because I don't bake Doom anymore, but the support for the cake pattern is actually better in Scala 3 because, again, because of the subtyping fixes and also the more uniform support of type members. So particularly if you're doing implicits with the cake pattern, which if you are, seek help. But if you're doing implicits with the cake pattern, it will work much, much better on Scala 3 than on Scala 2. I haven't actually tried it though. Let me know how it goes or something. As for the inline stuff and the new meta programming, I actually haven't touched that very much. Almost all of the stuff that I've been doing with Scala 3 so far, I've had to cross compile back to Scala 2 because I'm working in the library ecosystem and Scala 2 is going to be around for a while. So I tend to work in that subset of Scala. I am really, really, really excited though to start using some of that stuff like inline and like extensions and given and things like that. Like there's just a world of functionality that's there that will be much, much nicer once I can finally get to it. And finally, very, very quickly, the library ecosystem needs to cross-publish just like it always has. But again, that's a pretty easy thing. And the Scala 3 compiler, the payoff at the end is very stable, it's very fast. In many cases, it's faster than Scala 2 for compilation. And it's really, really, really a very pleasant tool chain to work with, like 10 out of 10. So I guess the point of my talk at the end of the day is like, I don't think we should be calling this Scala 3 because calling it Scala 3 conjures up images of like Guido like scowling at us and telling us that our Lambda syntax is wrong. I think we should just call it Scala because that's what it is.
He has to make you host.
Thank you.
Thank you.
So I think you did miss one thing that I was hoping you'd hit here, though, Daniel, which is the human factor. Having seen multiple megabyte Slack flame fests about trailing commas and cuddly braces, what are people going to be like when they have to choose between significant white space and curly braces? That's what I'm wondering.
My guess would be a lot of teams are just going to compiler flag it off.
You think not use the white space at all?
Yeah, I think a lot of teams that have strong opinions about it will probably just do that. I kind of like significant indentation in general. Like I'm one of those heathens that likes YAML. For me, I think it's pretty great. And I would encourage a lot of people to give it a try. But yeah, I think there are a lot of teams who will take advantage of the compiler flag and other tooling to kind of restrict it a little bit.
Fair enough.
But in the long run, they'll give in.
Exactly. They will relent.
Yeah, I think once you snuggle up with some significant white space with a good Netflix movie, it's like,
It's true.
That's it. Yeah. A question for you though, like significant white space, Dick mentions that. I also want to point out, we were talking about macros, we're talking about significant white space. Do you see the community taking an evolution and like leveraging more Scala 3 features and basically there being a divorce in the community of libraries that take advantage of the new stuff in ways that are not cross-compatible, right? Like, are we going to see an evolutionary, basically next iteration of the Scala ecosystem where things do get divided between who can use Scala 3 and who can't?
Yes. Yeah, I do actually see that happening. I think that the situation that we're in right now is library authors are cross-publishing, trying to make the migration as easy as possible, trying to make sure that like downstream usage is source compatible between the two versions, and all at the same time maintaining binary compatibility within their previous release lines in so much as possible. But I think that there's a day coming where a lot of the library ecosystems will break compatibility, and I think the next big compatibility break for all of them will be dropping support for Scala 2. I don't see that happening for a couple of years, just because, I mean, this is kind of a symbiotic thing, right? Like library authors want to support the downstream ecosystem wants to move in tandem with the library authors. So it's like, who's going to move first, and like this sort of three-legged race thing. But I do like Cats 3, for example, will be in code. We'll use the new type class encodings for Scala 3, and so it won't be compatible with Scala 2.
All right. Thanks for the talk.